Okay, good morning students. Today I am going to explain the permutations and combinations. Initially we will go through the permutations. Permutations. The basic concepts of permutations. Permutation means arrangement. Arrangement of things, arrangement of persons and arrangement of anything comes under permutation. So the number of permutations, how to find the number of arrangements of n different things taken or at a time in a row. The number of arrangements of n dissimilar things or different things, n different things. Different things. N different things taken or at a time. Taken or at a time. Out of n different things taken or at a time and arrange them in a row without repetition, that can be possible in NPR ways. NPR ways. NPR stands for the number of permutations of n dissimilar things taken or at a time in a row. No repetition is allowed, of course, here. That is given by NPR. This number is n factorial by n minus r factorial into r factorial. Sorry, this is n factorial by n minus r factorial is NPR. The number of arrangements of or dissimilar things taken out of n dissimilar things in a row is NPR, n factorial by n minus r factorial, because that is nothing but filling up of or blanks with n different things. Filling up of or blanks with n different things is given by NPR, the number of permutations of n dissimilar things taken or at a time in a row. This is nothing but n factorial by n minus r factorial. This is filling up of or blanks with n different things means you can fill this gap with n ways, because out of n different dissimilar things you can put anything here. So this gap can be filled in n ways. Since no repetition is taken place here, the thing which was used here cannot be arranged here. So the number of possible ways of arranging or filling up of this blank is n minus 1. Similarly, the number of possible ways of filling up of this blank is n minus 2. Like that, this can be filled with n minus or minus 1 or minus 1. Okay, that means n minus or plus 1. Right. It can be filled in n ways. It can be filled in n minus 1 ways. It can be filled in n minus 2 ways. That means the third place can be filled in n minus of 3 minus 1 ways. Like that, it can be filled in n minus of or minus 1 ways. Now, the required arrangements are by fundamental principle of counting. Here the product is considered. So n into n minus 1 into n minus 2 and so on, n minus or plus 1. This is the number of ways of arranging of or things or dissimilar things taken out of n dissimilar things and put them in a row. The total number of such arrangements are given by this product, n into n minus 1 into n minus 2 and so on, n minus r plus 1, which may be in factorial notation, which may be arranged as n factorial by n minus r factorial. In notation, it is NPR. So that is the notation of arranging of or dissimilar things taken out of n dissimilar things in a row. Okay. So NPR stands for the number of permutations, the number of permutations of or dissimilar things taken n things, taken out of n things. Okay. So that is the first one. NPR is n factorial by n minus r factorial, which is nothing but n into n minus 1 into n minus 2 and so on, n minus r plus 1, which is the number of permutations, non-repetition permutation. No thing is repeated twice. So number of permutations of or things taken out of n dissimilar things. Which is nothing but number of ways of filling up or blanks with n different things, so that nothing is repeated or repeated. Nothing is repeated. So NPR stands for, the notation NPR stands for number of permutations of all things taken out of n dissimilar things, so that no repetition is allowed. Repetition is allowed. Okay. Which is nothing but number of ways of filling up of or blanks with n different things, so that nothing is repeated. This is the basic concept of permutations. Now, the next point is NPR is n factorial by n minus r factorial may be written as n into n minus 1 factorial by n minus r factorial may be written as n minus 1 minus of r minus 1 factorial. I am adding 1 and subtraction of 1 to the denominator part, we get this one. This can be written in notation as n minus 1 p r minus 1. Of course, here r is always less than or equal to n. Both n and r are positive and r is less than n, where 0 is less than or equal to, r is less than or equal to n. So NPR equal to n into n minus 1 p r minus 1, which is similarly can be written as n into n minus 1 into, this can be written as n minus 2 p r minus 2. Like that you can write the NPR value. Okay. NPR equal to n into n minus 1 p r minus 1. n minus 1 p r minus 1. Same way this can be written as, this is n minus 1 factorial by n minus r factorial itself. It can be written as n minus 1 into n minus 2 factorial by n minus 2 minus of r minus 2 factorial, which may be written as n minus 2 p r minus 2 itself. Hence this one is n minus 1 into n minus 2 p r minus 2. Like that you can evaluate the NPR value. From these two, so it is clear that NPR by n minus 1 p or minus 1, n p r by n minus 1 p or minus 1 is clearly n. And similarly, n p r by n minus 2 p or minus 2 is n into n minus 1. Like that you can get the ratios of n p r and n minus 1 p r minus 1 or n p r and n minus 2 p r minus 2, like that. Next point. The number of permutations. Permutations in the sense arrangements of n dissimilar things. Dissimilar means different. The number of permutations of n dissimilar things taken all at a time. Suppose there is n different things taking all at a time. In how many ways they can be arranged in a row? The number of permutations of n dissimilar things taken all at a time in a row. Put them in a row is equal to npn, where the case or equal to n here. Here out of n dissimilar things, only or things is taken and arranged them in a row. But whereas here, if n dissimilar things is given, we are taking all the dissimilar things, all the things and arranged them in a row. So that can be happened in npn ways. Npn means n factorial by n minus n factorial. N minus 1 factorial is 0 factorial. 0 factorial value is always 1. Hence it is nothing but n factorial. If all the things, given things are arranged in a row without repetition, unless and otherwise specified, we have to consider without repetition. So here the repetition is not allowed. Nothing is repeated twice. So in such case, the number of arrangements of n dissimilar things in a row is n factorial itself. Next point. The number of permutations. The number of permutations of n dissimilar things. Yes, n dissimilar things taken or at a time in a row, so that k things, first one, always occur in the arrangement. Always included, occurred means included. Always included in arrangement. Always included in the permutation, always occurred in arrangement is equal to, out of n dissimilar things, are to be considered or to be chosen, and out of or these are to be arranged in a row, so that k things always occur, always included in the arrangement. They are compulsory included in the arrangement. So compulsory included in the arrangement means you have to put that k things out of n things aside. From remaining things you have to consider r minus k things from n minus k things and arrange them all in a row. So that is the total number of arrangements, such arrangements here. So, out of n things, those compulsory involved things to be put aside, and the remaining things are r minus k things are to be selected from n minus k things, and they have to arrange in a row. The total number must be arranged in a row. Okay. So, at first arrange k things, those always included in the arrangement, so that out of r things, r places, arrange k places at first. The remaining r minus k places can be filled with n minus k. So, n minus k p r minus k, n minus k p r minus k. Initially, you have to fill r blanks. There are r blanks to be filled here, that is r blanks. Out of r blanks, some k blanks are filled, The remaining blanks are r minus k. These r minus k blanks be filled with n minus k things. So, that can be arranged in n minus k p r minus k. And initially, out of r places, k to be filled with r p k. That is the problem here. Okay. K things, in which k things always included, Here k cannot be greater than r, of course. Here k cannot be greater than r. So, 0 is less than or equal to, k is less than or equal to, r is less than or equal to n. Okay. This is one important point. Out of n dissimilar things, you have to arrange r things, in which k things are compulsory included in the arrangement. The second point is related to this one. The k things always do not, otherwise never included, never occurred in the arrangement. Such arrangements is k things never occur in the arrangement, Out of n things, or things to be considered and arranged in a row, so that k particular things do not occur in the arrangement. So, that can be done in n minus k p or ways, because you have to fill r blanks, with n minus k things, because these k things do not occur in the arrangement. So, that can be happened in n minus k p or ways. Okay. Out of total n different things, only r to be arranged, but whereas there is a restriction over the permutation, restricted permutation. These are all called restricted permutations, in which the permutation always included k particular things and do not include that k particular things. Okay. So, that k particular things to be arranged, So, that can be happened in r p k into n minus k p or minus k, and whereas these k particular things do not occur in the arrangements are only excluding those particular things out of total number of dissimilar things, and arrangement of r things in a row, that can be possible in n minus k p or ways. So, this is the permutations based on the restrictions. We are imposing certain restriction on the permutation. That restriction is included particular number of things and do not include particular number of things. Okay, in particular k equal to 1, special case, third case. A particular thing is included, a particular thing is not included. If k equal to 1, then if k equal to in particular if k equal to 1, that means a particular thing is not included and included in the arrangement. Then permutations so that the particular thing be included is equal to permutation so that the particular thing, because k equal to 1, a particular thing is included in the arrangement is taking k equal to 1 or p1 into n minus 1 p or minus 1, or p1 is or factorial by or minus 1 factorial, which is nothing but or itself. So you can take it as or. So therefore or into n minus 1 p or minus 1, n minus 1 p or minus 1, so that that particular thing always included in the arrangement. And permutations, number of permutations, so that the particular thing do not included in the arrangement, do not included is excluding that particular thing out of total number of things and arrange or things in a row that may be happened in n minus 1 p or base. So this is a particular case of above said 1 and 2 cases. Okay. The third case is a particular case of 1 and 2 cases. Once k takes the value 1. Similarly, you can take k equal to 2, k equal to 3 like that. K may takes less than or equal to or. Particular things included in the arrangement and particular things do not included in the arrangement. Restricted permutations. Next one. Next things. Okay. This is one important point. The number of permutations n things of one kind and n things of one kind and things of second kind, another kind. All are dissimilar, of course. All are dissimilar. In a row, the number of permutations of n things and different things are, of course, of one kind and different things of one kind and n things of another kind, all are dissimilar in a row, So the row alternatively is equal to 2 factorial into n factorial into n factorial itself. 2 factorial into n factorial into n factorial. This is very useful in arranging the boys and girls in a row. They sit in alternatively. They sit alternatively. The boys and girls, n boys and n girls, are arranged in a row so that they stand or sit alternatively is 2 factorial into n factorial ways. Because the arrangement may be started with boys or the arrangement may be started with girls. So based on that we get 2 twice to that of n factorial into n factorial ways. Hence I am taking 2 factorial into n factorial into n factorial. So n different things of one kind. Suppose n boys and different things of another kind. N girls may be arranged in a row so that they come alternatively. Is 2 factorial into n factorial into n factorial. This is one important. For example, this is the best example. Arrangement of number of arrangements. Number of permutations or arrangements. N boys and n girls in a row alternatively is 2 factorial into n factorial into n factorial. Okay. In above case, in the same case, suppose we are in need of number of permutations of n different things of one kind and n different things of another kind, so that the permutations started with the first kind. The started with first kind arrangements are only n factorial into n factorial. You do not get 2 factorial in such case. So starting with only boys, suppose starting with only boys means you have to fill 2n blanks starting with boys, boy and girl, like that you have to arrange all the 2n blanks. That can be possible in n factorial ways into n factorial ways. You do not get 2 factorial because once you specified the initial one as boy, you do not get 2 factorial. That is to be observed here. This is one important point. Okay. Next one. The number of ways in which n things, all are different, of course, all are different and different things of one kind and m different things of second kind, another kind. The number of ways in which n different things of one kind and m different things of another kind, so that m different things of another kind, the second kind things come together. The second kind things or come together. Suppose, for example, you have to consider n boys, n girls, and arrange them in a row, so that all the girls come together. Okay. Such arrangements come together. Such number of arrangements is equal to you have to arrange m plus n gaps with n different things of first kind and m different things of another kind, but m things to be come together. Okay. In such case, assume all the second kind of m different things as one thing, as m different things of second kind as one thing, so that the number of things becomes n plus 1. Arrange those n plus 1 things in a row. That can be possible in n plus 1 factorial. Whereas these m things internally can be arranged in m factorial ways. Okay. Initially, choosing all these second kind things assuming as one thing, so that the total number of things becomes n plus 1. Arrange n plus 1 things in a row, taking all n plus 1 things at a time. The arrangements are n plus 1 factorial. In each such an arrangement, internally these m different things can be arranged in n factorial ways. This is internal arrangement of each such an arrangement. Hence, the required number of arrangements of n plus 1 factorial into m factorial. In case the first kind things come together, then the number of such permutations are The number of such permutations are equal to, choose these n different things as one thing and arrange the total number of things. That means in such case the total number of things becomes m plus 1. That m plus 1 things may be arranged in a row in m plus 1 factorial. In each such arrangement, internally these n different things may be arranged in n factorial ways. So, observe this difference. Once n different things come together, in case the first kind things come together, the number of ways of such permutations becomes m plus 1 factorial into n factorial. In case of second kind things come together, that is n plus 1 factorial into m factorial. Once this is one subcase, okay. Number of permutations, in this case, number of permutations, so that n different things come together. Of one kind come together, and m different things of second kind, of course, of second kind also come together. Is equal to n different things of one kind come together and n different things or of second kind also come together. Such arrangements of n different things of one kind and m different things of another kind in a row is nothing but m things are assumed as one thing and m things, different things are assumed as one thing. These two things can be arranged in 2 factorial ways in a row, and each such an arrangement internally the n different things can be arranged in n factorial ways, and this m different things can be arranged in m factorial ways. So this is arrangement of n different things and of one kind and m different things of another kind in a row, so that each kind of things come together. Come together is 2 factorial into n factorial into m factorial. This is also one important point. Suppose there is 10 boys, for example, 10 girls. How to arrange 10 or 5? Take this one. How to arrange these 10 boys and 5 girls in a row so that boys come together and girls come together is nothing but 2 factorial into 10 factorial into 5 factorial. All the boys come together and all the girls come together can be done in 2 factorial into 10 factorial into 5 factorial. Okay. Whereas only girls come together arrangements. Only girls come together arrangements is 10 plus 1 factorial into 5 factorial. That is 11 factorial to 5 factorial. Only boys come together. That can be done in 5 plus 1 factorial into 10 factorial. That is 6 factorial into 10 factorial. Like that you can arrange the, you can take the permutations, linear permutations. Linear in the sense arrangement them in a row. So the number of linear permutations of n different things of one kind, m different things of another kind, that can be made so that second kind only come together is n plus 1 factorial into m factorial. First kind things are only come together is m plus 1 factorial into n factorial. Both the kinds comes together in the arrangement is based on the nature of the things, they come together is 2 factorial into n factorial into m factorial. So this is related to restricted permutations. This is the points, these are the points related to restricted permutations. You can take that example. For example, I will explain this one through an example. Okay. Let us take this one example. Let us take a simple problem related to this one point. Ten boys, 10 girls are given. Then number 1. Number of permutations. So that linear permutations, of course. Number of permutations so that boys and girls come alternatively. They come alternatively. That may be happened as 2 factorial into 10 factorial into 10 factorial. 2 factorial into 10 factorial into 10 factorial. The number of linear permutations so that boys and girls come alternatively. Second, number of permutations Of course, linear permutations. So that only boys come together. Number of permutations so that only boys come together is here. Only boys come together means assuming all the boys as one person, the total number of persons becomes 11. So 10 plus 1, the 11 persons can be arranged in 11 factorial ways. For each such an arrangement, internally the girls can be arranged in 10 factorial ways. That is 11 factorial into 10 factorial ways. Similarly, the third case, the number of linear permutations so that only girls come together in the arrangements. Out of 10 boys and 10 girls are arranged in a row, number of linear permutations of these 10 boys and 10 girls can be arranged so that only girls come together is assuming all the girls as one person, then 10 boys plus 1 person, the total number of persons are reduced to 11. So 11, 10 plus 1 factorial, 11 persons may be arranged in 11 factorial ways, and each such an arrangement, the girls can be arranged in 10 factorial ways. Hence, in such case also 11 factorial into 10 factorial. Next one. The number of linear permutations. The number of linear permutations so that 10 boys come together, all the boys come together, and 10 girls come together. Is equal to, assuming all the boys as one single boy and all the 10 girls as single girl, these two can be arranged in 2 factorial ways, either BG or GB, like that. In this place, we have to arrange 10 boys in 10 factorial ways. In this place, 10 girls can be arranged in 10 factorial ways internally. So that in 2 cases we get 10 factorial into 10 factorial. In this case also we get 10 factorial into 10 factorial. Either this, or stands for addition. So that we get twice to the top 10 factorial into 10 factorial ways. So these are the different ways of arranging the boys and girls in different restrictions, based on the different restrictions in a linear form. Next point. When repetition is allowed, the number of permutations, of n dissimilar things the number of linear permutations, of course, this is linear. The number of linear permutations of n dissimilar things taken all at a time of course, taken or at a time. Taken or the number of linear permutations of or dissimilar things out of n dissimilar and different things so that repetition is allowed. Repetition is allowed. Once the repetition is allowed, the number of ways of arranging or dissimilar things taken out of n different dissimilar things. So here you have to fill or blanks. You have to fill or blanks out of you have to fill these or blanks with n different things. Each blank may be filled in n ways, because out of n different things anything may be put here. You can use the thing whatever used here, you can use it here also like that. So here also you can fill this gap in n ways, you can fill gap n ways. Each and every gap can be filled in n ways, because you can use anything in any number of times. Repetition is allowed is like that. So that it is given by n into n into n or times. In such case we get n power or itself, n power or. If the repetition is allowed, the number of permutations of or dissimilar things taken out of n different dissimilar things is n power or itself. The number of linear permutations of n dissimilar things taken all at a time is n into n into n into n times, because or is n in such case, that is n power n itself, taking or equal to n. Next, similarly, the number of permutations, linear permutations. The number of linear permutations of taken out of n dissimilar things. The number of linear permutations of n different things taken not more than or at a time. At a time. This terminology is more important. Taken not more than or at a time means you can take less than or equal to or things at a time. Less than or things at a time. And repetition is allowed. Not more than or at a time, and repetition is allowed. Not more than or at a time means you can take, of course, not repetition is allowed. Not repetition is allowed. More than things taken not more than or at a time is. You can arrange one thing and you can arrange two things, three things, like that. You can arrange or things taken out of n different things. So that was happened NP1 or NP2 or NP3, like that you can arrange or things in a row. If no repetition is allowed. No repetition is allowed. The number of linear permutations of n different things taken not more than or at a time. Not more than means less than or equal to or at a time. Not more than or at a time. Okay. The number of permutations of n different things taken not more than or at a time is NP1 plus NP2 plus NP3 and so on. NP or itself. If repetition is allowed in this case, this is the case not repetition is allowed. If repetition is allowed, in each and every case, we have to take NP1, NP2 and P3 like that. Out of n things, arrangement of one thing, arrangement of two things, arrangement of three things, arrangement of four things, like that you can take or things. In case of repetition is not allowed, this is n, this is n square, this is n cube, like that. The number of linear permutations, linear arrangements of n different things taken not more than or at a time. So that the repetition is allowed. Repetition is allowed. Once taking one thing, that means filling up of one gap, two gaps, three gaps, like that. Either this, like that. Or gaps, filling up of or gaps. Not more than or at a time means you can choose one thing out of n different things, you can arrange it. You can choose two things, you can arrange two things, so that the repetition is allowed. Like that, that is nothing but n, next n into n, that is n square, next n into n into n cube, like that, n power r. N plus n square plus n cube and so on. If repetition is not allowed, NP1, NP2, NP3, like that. If repetition is allowed, that is n plus n square plus n cube and so on, n power r itself, which is equal to, these are all in GP. Sum of all terms in GP in which the initial term is n and the common ratio is n itself. So, that is A into n into R stands for common ratio is n power r minus 1 by n minus 1. This is n into n power r minus 1 by n minus 1 is the required, which is r plus 1 minus n by n minus 1. Either this or this or this. Things taken not more than or. Not more than or means you can take one, or you can take two, or you can take three, like that. You can arrange the things out of n different things. Each thing may be repeated any number of times. So that can be possible. It can be filled in n ways. It can be filled in n ways, and whereas this can also be filled in n ways, because the thing that was used here, you can use it here also. So n into n square ways. Similarly, this can be filled in n, this can be filled in n, this can be filled in n. So n cube ways, like that. You can arrange the number of things in a row, so that the repetition is allowed is n plus n square plus n cube and so on, n power r. This is one important point. These points to be remembered while going through the problems. These are all very important points. Once if the repetition is allowed and out of n different things taken not more than or at a time, taken more than or, not more than, instead of not more than, taken more than or at a time. More than or at a time is, if repetition is allowed, the number of permutations of n different things in a row is n power r plus 1, n power r plus 2, like that you can take n power n. Out of this, you can take n power r as common, so that we get n square and so forth, n power r from 1 to n minus r terms, and that is given by n into n power n minus r minus 1 by n minus 1 itself. You can simplify this one. More than r at a time means you can take r plus 1, you can take r plus 2, you can take r plus 3 and arrange them in a row out of n different things, so that each thing may be repeated any number of times. That is the question here. We will go through simple problems related to these concepts, and related to the permutations. This is very important point. N plus 1 P or n plus 1 P or equal to, this is one important, n plus 1 P or, okay, n plus 1 P or equal to n P or plus or into n minus 1 P or minus 1. Oh, n P or minus 1. N plus 1 P or, the number of permutations of n plus 1 different things taken or at a time is n plus 1 P or, which is nothing but the number of permutations of or things taken out of n things plus or into the number of permutations of or minus 1 things taken n things. A particular thing is included and a particular thing is not included. A particular thing is included in the arrangement means this one, because out of all things or places, one place to be filled with always, so the remaining or minus 1 gaps can be filled with n things in np or minus 1. So this is the number of ways of arranging a particular thing to be included in the arrangement and do not include in the arrangement. So this is number of ways of arranging, number of ways of arranging n plus 1 things, different things of course, so that a number of ways of arranging or things out of n plus 1 things, different things, so that one particular thing do not included in the arrangement, included in the arrangement, do not include in the arrangement means the particular thing which does not comes in the arrangement to be set aside and the arrangements to be made out of n different things taken or at a time. So this one is number of arrangements of n plus 1 different things taken or at a time. So that a particular thing always included in the arrangement. A particular thing always included. Do not included here and included here. Always included in arrangement. So, n plus 1 p or is nothing but sum of the arrangements in which a particular thing included and a particular thing do not include. That gives us the total number of arrangements of n plus 1 different things taken or at a time. This is one important relation between n plus 1 PR and PR and np or minus 1.